Dear students, in previous class we discussed the root test. What is root test? If modulus of x power 1 by n less than or equals r, let r equals limit modulus of x power 1 by. If modulus of x power 1 by n less than or equals r, then the series sigma xn converges absolutely. If it is greater than r, then sigma xn diverges. Okay, then sigma xn diverges. That is root test. And the proof is immediate. Now, come to its corollary. There is a result. Let x equals xn be a sequence of real numbers, and suppose that limit r equals limit x power 1 by n. R equals limit modulus of x power 1 by n in r. Then sigma xn absolutely converges. If r less than 1 and diverges if r greater than 1. So this result is immediate, that is, follows immediately from the root test. If x equals xn be a sequence of real numbers, and when r equals limit modulus of x power 1 by n, then modulus of xn power 1, or more precisely, it is limit mod x power 1 by r equals limit mod xn power 1 by n. Then the sigma xn is absolutely converges if r less than 1 and diverges if r greater than 1. How? What is r here? Here r equals limit modulus of xn power 1 by n. So since r fall in r, and if r less than 1, there exists some r1 fall in r such that r less than r1 less than 1. R less than r1 less than 1 means what is r1 minus r? R1 minus r is strictly positive. R1 minus r is positive. Now, since limit modulus of xn all power 1 by n equals r, then by the definition of this limit, for all epsilon positive, there exists some k fall in n such that modulus of mod xn power 1 by n minus r strictly less than epsilon. Okay, so that means r minus, so it is minus epsilon means r minus epsilon strictly less than modulus of xn power 1 by n strictly less than r plus epsilon. Agreed. What is epsilon? Epsilon is a positive quantity. So put epsilon equals r1 minus r. Okay. So that means r minus of r1 minus r strictly less than modulus of xn power 1 by n strictly less than r plus r1 minus r. Clear? Okay. That means r minus minus r. So it is 2r. So 2r minus r1 strictly less than modulus of xn power 1 by n strictly less than r and r cancelling each other, r1. Then come to the right side inequality. Modulus of xn all power 1 by n strictly less than r1 implies sigma modulus of xn power 1 by n strictly less than sigma r1. What is r1? R1 lies in between 0 and 1, or r1 less than 1. So sigma r1 is a geometric series, or sigma r1 should be, if r1 less than 1, then what I get from a root test. So sigma modulus of xn power 1 by n by root test. By root test, sigma modulus of xn power 1 by n converges. Therefore, sigma xn converges absolutely. Okay. By root sigma modulus of xn power 1 by n strictly less than sigma r1, that is less than 1. Then by root test sigma modulus of xn all power 1 by n converges, or sigma xn converges, sorry, by root test not modulus of 1 by n, sigma xn modulus of xn converges, that is sigma xn converges absolutely. So that is the proof of this corollary. This corollary is also important, that is used for testing the absolute convergence of a given series. Okay. Now, what about its second part? If it is greater than r, then diverges. Suppose r equals this one, limit modulus of xn power 1 by n, r fall in r. If r greater than 1, what happens here? If r greater than 1, then there exists k fall in n such that modulus of xn power 1 by n, modulus of xn power 1 by n greater than 1. Okay, greater than 1 for all n greater than or equals k. So that means here sigma xn diverges. Why sigma xn diverges? Again from root test. What is root test? Root test says that if r equals modulus of xn, sorry, or modulus of xn all power 1 by n greater than or equals r, then sigma xn diverges. Clear? So, now there is an important test for the convergency, that is a ratio test, limit comparison test, a root test, and the next one is ratio test. Ratio test is a very crucial result for testing the absolute convergence of a given series. So what is ratio test? A ratio test states that let x equals xn be a sequence of non-zero real numbers. X equals xn be a sequence of non-zero real numbers. If there exists r fall in r, if there exists a real number r such that 0 less than r less than 1, comma k is any natural number, then modulus of xn plus 1 by xn, modulus of xn plus 1 by xn less than or equals r for all n greater than or equals k, then sigma xn converges absolutely. Sigma xn converges absolutely. If it is greater than or equals r, then it diverges. Okay, if it is greater than or equals r, then it diverges. This is a ratio test. So its proof is again immediate. So how? Consider what is xn? Xn be a sequence of non-zero reals. So if modulus of xn plus 1 by xn less than or equals r hold, if modulus of xn plus 1 by xn less than or equals r, it is true for every n greater than or equals k. So that means, what about modulus of xk plus 1 if greater than or equals k? So put n equals k, it is modulus of xk plus 1 by xk when n equals k. So it is less than or equals r. Clear? That means modulus of xk plus 1 less than or equals r into modulus of xk. Agree? Okay. Again, modulus of xk plus 2. By using this result, modulus of xk plus 2 less than or equals r into modulus of xk plus 1. But what is xk plus 1 less than or equals r into modulus of xk? So it is less than or equals r into modulus of xk by using this result. That equals r square into modulus of xk. So modulus of xk plus 2 less than or equals r square into mod xk. So what about a modulus of xk plus 3 from here? It is less than or equals r cube into modulus of xk. Proceeding like this. What is the modulus proceeding like this? What is modulus of xk plus m? Modulus of xk plus m less than or equals r power m into modulus of xk. Okay. Taking sigma on both sides. So what is sigma modulus of xk plus m? it is less than or equals sigma r power m into modulus of x power. Enough? Yes. Then, but what is r? R lies in between 0 and 1. That is from hypothesis. Our choice of r lies in between 0 and 1. So, therefore, sigma r power m, that's a geometric progression with a r less than 1, so it should convert this. Sigma r power m into mod x m also convert this. So, by comparison test, sigma mod x power modulus of x k plus m convert this. That means modulus of sigma mod x k plus m convert this means x k plus m convert this absolutely. So, generally here x series sigma xn convert this absolutely. Agree? So that is ratio test. If r equals, if modulus of xn plus 1 by xn less than or equals r, then sigma, if r lies in between r lies in between 0 and 1, then sigma xn convert this absolutely. When it is greater than or equals r, xn plus 1 by xn, modulus of xn plus 1 by xn greater than or equals r, then prove that, or modulus of xn plus 1 by xn greater than or equals 1, then it diverges. Greater than or equals 1, it is diverges. That is the result. Modulus of xn plus 1 by xn less than or equals r. If r lies in between 0 and 1, then sigma xn converges absolutely. And if this ratio, modulus of xn plus 1 by xn greater than or equals 1, then it diverges. How to prove that one? Consider modulus of xn plus 1 by xn greater than or equals 1. That means modulus of xn plus 1 greater than or equals mod x. Okay? For all n greater than or equals k. That means modulus of xn plus 1 or xk plus 1. So it is for n greater than or equals k, choose n equals k, modulus of x k plus 1 greater than or equals mod x. Great. What is mod x k plus 2? Modulus of x k plus 2 greater than or equals mod x k. Proceeding like this, modulus of x k plus m greater than or equals mod x k. Enough? So modulus of xk plus m greater than or equals mod xk, that means modulus of xk less than or equals modulus of xk plus m. Agreed? So by that, so from here, what about limit? So it is limit xn differs or limit xk differs from 0. Then by nth root test, this xn plus 1 or sigma xn diverges. Limit xk differs from 0 means limit xn differs from 0. So by nth root test, by the nth test, as limit xn differs from 0, then we have sigma xn not converges means it diverges. Okay, nth term test. Clear? So the second part of ratio test is proved by using nth term test. Limit xn differs from 0. So from nth term test, the sigma xn diverges. Agreed. So this is an important result. Ratio test is a crucial result for testing the absolute convergence or the divergence of a given series. If modulus of xn plus 1 by xn less than or equals r, if r lies in between 0 and 1, then it should absolutely converges. If it greater than 1, then it diverges. Modulus of xn plus 1 by xn greater than or equals 1, then it is diverges. Okay, right. Then consider a simple result that is deduced from this ratio test. If x equals xn is a series of non-zero real numbers, and suppose that if r equals limit modulus of xn plus 1 by xn, then if r less than 1, if r less than 1, sigma xn converges absolutely, and if r greater than 1, it sigma xn diverges. When r equals limit x modulus of xn plus 1 by xn exists, and if r less than 1, sigma xn converges absolutely. If it greater than 1, then sigma xn diverges. Let's again immediate. How? The proof is like the proof is the same as that of the corollary of a root test. Consider r equals limit of this one, limit of modulus of xn plus 1 by xn. If r less than 1, then there exists some r1 fall in r such that r less than r1 less than 1. Okay, r less than r1 less than 1. Then r equals limit of this one means, so this gives for all epsilon positive, there exists some k fall in n such that modulus of xn plus 1 by xn minus r strictly less than epsilon. Modulus of mod xn plus 1, modulus of mod xn plus 1 by xn minus r strictly less than epsilon. That means r minus epsilon strictly less than modulus of xn plus 1 by xn strictly less than r plus epsilon. Again put up, what is epsilon? Since r1 minus r is positive, so epsilon equals, choose epsilon equals r1 minus r, r1 minus r, which should be positive. r1 minus r, that is always positive. So by substitution r1 r minus of r1 minus r, that is 2r minus r1 strictly less than modulus of xn plus 1 by xn strictly less than r1. r plus r1 minus r, so it is r1. Come to the right side equality. Consider sigma, so consider this one only, modulus of xn plus 1 by xn strictly less than r. So it is modulus sigma, what do you get? Sigma modulus of xn plus 1 strictly less than sigma r into modulus of xn. Sigma r into mod x. Okay. So consider, so it is by a ratio test, not from here, sigma xn plus 1 modulus of, consider this one, modulus of xn plus 1 by xn strictly less than r1. What is r1? r1 less than 1. Modulus of xn plus 1 by xn strictly less than r1, but r1 less than 1, therefore modulus of xn plus 1 by xn strictly less than 1. So by a ratio test, what do you get? Sigma xn converges absolutely. Okay. Then is divergency. When r greater than 1, this also diverges. That's again by using the same arguments. Clear? If r equals limit of modulus of xn plus 1 by xn, then r greater than 1, what do you get? Modulus of xn plus 1 by xn greater than 1. Enough. Modulus of xn plus 1 by xn greater than 1. Again by a ratio test, the sigma xn diverges. The series sigma xn diverges. Okay. So these are the three important tests for testing the convergency of or absolute convergence of a given series. That is limit comparison test, ratio test, and the root test. Okay. So consider, take a problem. Test the convergence of sigma 1 by n plus 1 into n plus 2. How to test the convergency? So far we have n square should less than n plus 1 into n plus 2. N square less than n plus 1 into n plus 2 for all n falling n. Okay. N square should less than n plus 1 into n plus 2 for all n falling n. Therefore, 1 by n plus 1 into n plus 2 should strictly less than 1 by n square. Clear? That means sigma 1 by n plus 1 into n plus 2 strictly less than sigma 1 by n square. What is sigma 1 by n square? Sigma 1 by n square converges. Therefore, by comparison test, sigma 1 by n plus 1 into n plus 2 converges. Agreed. So, by taking limit comparison test, what about its modulus also converges. Therefore, sigma 1 by n plus 1 into n plus 2 converges absolutely. Enough. Okay. So, this is by using the solution is by using limit comparison